Here we are on page 4, the second part of page 4, problems 13 through 17. They want us to match the differential equations with the appropriate slope field, then use the slope field to sketch the graph of the particular solution through the highlighted point 32. So I would say the first thing I want to make note of here is this point 32. If we look closely at that graph, these slopes here are not on the integer values of x. So in other words, this is not 3 little slopes over and 2 high. It actually looks like it's about 4 over and 3 high. So be very careful when we're doing this that we don't make that mistake of thinking that this one right here goes through the point 1, 1 or 1 or 2, 1 or something like that. All right, so let's take a look. Matching the differential equations. So first of all, when I see just an x, I'm going to automatically look for slopes that are vertically the same. Look for that pattern. So as I go through this, I can see that these slopes vertically change here. They're changing here. Here they look to be always the same, so we'll keep C in mind. Here they're changing, and here they're changing. So it's got to be C. Let's just make sure that we understand why it is C, though. First of all, if x is positive, so is the slope. So to the right of the y-axis, all of these slopes here are positive. To the left, they're all negative. So that makes me believe, again, it's also for 13. Also, as x increases, so does the slope. So as I travel further out this x-axis, my slopes are increasing. And so I am inclined to believe that this is C, belongs to number 13. Similarly, 14 has just a y. So now I'm looking for the same slopes horizontally. And if I look at graph A, I see that those are changing horizontally. Graph B over here, they are changing. Graph D down here, they are changing. I've got some positive slopes here, negative slopes here. But when I look at E, all the same slopes as I travel across. So 14 has got to be E. Okay. We're going to match up the slope fields, then we'll go back and we'll draw the particular solutions. Okay, x minus y. So let's see here. What would make dy dx 0? Would be if x and y were the exact same values. So what I want to do is I want to look for values that along this diagonal here are going to be the same. So as we scan through this, that could be, these look to be pretty close to the same values. Here, these are clear. Well, they could be too. They look to be pretty much the same. Down here, they look like they could be pretty much the same here. So that didn't offer me much help in the way here. How about this? dy dx is going to be positive when x is greater than y. So when is x going to be greater than y? Well, x will be greater than y. Let's say out here. So in other words, anywhere below that line that we were just looking at here, where the x coordinate is greater than the y coordinate. We're looking for it to be positive, and dy dx is going to be negative whenever x is less than y, or whenever y is greater than x. So what are we looking at here for number 15? Out here, I have slopes that are all positive. Up here, slopes that are all negative. So I'm inclined to think that A, but let's just verify here. Definitely in this point here, our x is greater than y, but we have a negative slope, so that can't be it. And down here, same thing. I've got negative slopes out here. So A has got to be 15. 16, we have y minus x. So it's a very similar setup. So we might look at this and realize that D looks like A in a lot of ways. So I'm immediately thinking D might be the answer. But let's just try to analyze this a little bit. dy dx is 0 when y is equal to x. So that same diagonal. So that's not much help. dy dx is positive when y is greater than x. So that's everything above this, and sure enough, this is all positive up here, and it would be negative when y is less than x. That is anywhere out here, and sure enough, that's negative. So 16 is D. Process of elimination would lead me to conclude that 17 is B, but let's go ahead and analyze this. So here, dy dx is going to be 0 when y is 0. So what I'm looking for are horizontal tangent lines, horizontal slopes on the x-axis. Look at B. I see that. dy dx is undefined when x is 0. That's on the y-axis. So if I look at the y-axis, I have slopes that are vertical here, little vertical lines. Now it's hard to see, but if we look here to the left of that line, the slope is positive, and then all of a sudden it's negative. And so the only way to get from positive to negative or negative to positive is either through 0 or by going undefined. And that's exactly what happens here, because we clearly see there are no slopes of 0 there. So for 17, we should get B. Now let's go back and draw the particular solution through the point 3,2. So again, what I want to do is try to match up those slopes. So let's see, as I come through here, I see that it's coming down. Now notice it's slightly negative here, and it's going to go steeper here, slightly a little less negative here, a little positive here. So we want to be very careful as we come down here. So this is a tricky one. Actually, it's the hardest, I think, of all 5 of them, because part of me wants to follow these and go up, but if I'm not careful, this slope here actually comes down, and I don't know, somewhere down here we can go ahead and turn if we want to, but I would, surmise we could also just continue drawing this and get a nice, just a straight oblique line here. It doesn't have to curve. Up here it definitely would curve. Down here it's going to get a curve down as we travel through here, but there would be a point here where it's just going to be a straight line. Okay, let's take a look at B. Well, as we come through here, we have this slope drawn for us right here, and as we travel up and we trace our way up, and as we trace our way down, remember, as we go through those slopes, we want to match everything up. So that would be that solution there. For C, we might even look, we've had a little bit of experience with this back up on problem number 7. This looks like little parabolas here, so make sure as we do that we match everything up. Okay. We're going 0 here, slightly negative, and we increase there. Over here in D, I'm going to the right, keeping my slopes traveling the same as the little segments around it. We'd get something that looks like this, and then all of a sudden it turns here, and it comes down. And what we'd have here is we would actually have a horizontal asymptote if we were looking at that actual graph. Not a horizontal, I apologize, an oblique asymptote. And then finally in this last one, E, we have slopes that go up like this, and then they come down. And again, we're going to have, in this case, a horizontal asymptote. It would approach 0, but it would never actually get to 0. So a little tricky drawing some of these graphs, especially this one here. It can be a little tricky as to know which way these slopes are going. So I would assume on the test, if they were to give you one like this, it'd be a little clearer as to what your particular solution would look like. But that gets us through page 4. Thank you.